What occupation takes airplanes, four-wheel drive trucks, and research biologists navigating across the landscape equipped with radio antennas? Tracking of the Indiana bat, an endangered species about the length of a business card and the weight of a quarter. These small mammals play an essential role in our ecosystem and are our #1 natural control of night-flying insects. Information about the migration of these bats had been minimal at best, but thanks to groundbreaking research over the last few years, important data has been discovered about the Indiana bat's journey. Traveling and studying the Indiana bat's migration, however, creates enormous challenges for researchers. Join us as we explore the complex steps of a spring migration study and the incredible expedition of this small, endangered animal known as the Indiana bat.
Indiana bats had a big decline in population numbers in the 60s, and when it was realized that their numbers were not bouncing back, they were put on the endangered species list. Part of it was people not understanding how important bats were, and they were actually outright killing them. And then there was also changes in their hibernacula, where people would change the openings of the caves and change the airflow and the temperature. So then cave gating became popular for Indiana bats' hibernacula, and that helped keep people out of the caves, and the numbers of the bats started to increase after that. So a lot of the decline with the species was human-induced. And then more recently, in 2006, white nose syndrome showed up in the States from possibly Europe, and has been killing hundreds of thousands of bats of all species in caves, or many species, and Indiana bats is one of them. So white nose syndrome is caused by a fungus that actually infects the epidermis layer of bats. So it gets in their skin and it irritates them, and in the winter that causes them to wake up more than they're normally used to waking up, and it uses up their fat reserves, and they can't make it through the winter, and there's no food on the landscape in the winter for them to go out and replenish their fat stores. So basically they starve to death.
White nose is something that is very concerning, and this migration information can also help us understand potentially how the white nose is being transmitted and how it's being moved from cave to cave, because these migrants are picking it up from other bats into maternity colonies that are coming from other caves that may be white nose infected. They're picking up the spores, and as they go back to their hibernaculum, this is how white nose is most likely being spread, as bat-to-bat contact. There's very little known about how these animals navigate across the landscape from their winter hibernaculums to their summer grounds, and understanding that can help with industry and the development of such things as wind power and wind facilities, which have been documented to kill bats as they migrate. In their migration route, there are specific things that are needed. They need foraging bouts where they will stop for maybe 30 minutes to an hour and feed, and those feeding areas are extremely important. Safety corridors, can you migrate across the landscape without getting eaten by an owl or a hawk early in the evening? They also need roost trees, and so forest management is really important.
The more we can learn about what Indiana bats do once they leave hibernacula and move towards summer habitat, the better we can assess what suitable habitat looks like and whether or not suitable habitat occurs in the footprint of proposed actions.
What was previously known about Indiana bat migration was mostly from band recoveries. Bands are typically put on during the summer where the bats are in their maternity range. And then in the winter we do hibernacula counts where we count the bats in the caves to determine population numbers. And sometimes those bands would be recovered in those caves. So then you can look and see where they were banded originally and get a start and end point of that migration. So we get a distance and we get a direction of the bat's travel, but we don't have information about what happens in between.
This project is quite complicated. It takes a tremendous amount of manpower. We start out with a cave crew that will actually go to the cave to pull bats out of the hibernacula. Timing on that is very, very crucial.
When we start a spring migration project, we basically have to look at the weather. That's what determines when we start. So I monitor the weather stations for a couple of weeks before the beginning of April. And once we have several days of daytime temps in the 70s and nighttime temps in the 50s or high 40s, then we travel to the cave.
Most of the caves that we've been working with are in fairly remote areas. To get to the caves themselves is quite a journey. There is usually a canoe ride across the river, a hike up a hill,
and then hike for 15-20 minutes through the woods, sometimes crossing another body of water.
We've had complications even getting into some of the caves, being that they're privately owned, and landowners have complications letting us in. One guy collects his water out of the cave, and so he complains about boot water when we go in there. He can taste our boots.
And once we get to the cave, we have to make sure that we follow decontamination protocols so that we don't spread white nose syndrome. That requires putting on overalls and Tyvek suits and having gloves.
Once they get into the cave, there's the complications of caves. I mean, these things are created by water eroding away limestone. Some of the passages are tight and narrow. Caves are very complicated systems, and you're looking for these cold air sinks is where the bats like to hibernate. So you got to know where the bats are even at. So if you don't know that, you can even get lost in these caves trying to find the bats. So we want to get in as quickly as possible, grab the bats. We try to sex them at the cave so that we're taking back just the females.
Male.
Female.
There's a group of the cave crew that stays behind and does all the morphometric measurements on the males, bands them, measures them, tags them, puts them back in the cave, and then all the females get transported back down the hill, across the river, up to where the teams are set up that have already been activating transmitters. And they're prepping and ready for the bats to arrive.
At this time, the bats are divided among the crew at their workstations, and the process of recording important data begins. This includes confirming the species and sex of the bat, recording mass, forearm measurement, and wing damage assessment.
If it was white nose scarring, it would be illuminated kind of white.
A uniquely numbered band is placed on the forearm. Then comes one of the fundamental steps in the study of the Indiana bat spring migration: attachment of tiny radio transmitters.
There are geo trackers and there are GPS transmitters, but our bats weigh between 6 and 8 grams when they come out of hibernation. And to give you a reference, a quarter weighs 5.75 grams. So our bats weigh slightly more than a quarter. The smallest GPS satellite transmitter is right now 2 grams, and that's pretty small, but yet that's 30% of our bat's body weight. So we are also confined by our federal permits. We're not allowed to put transmitters that weigh any more than 5% of the bat's weight. So the transmitters that we're putting on these bats weigh 0.4 grams or less. So it's a very, very tiny transmitter.
In order to secure the transmitter, each bat has the fur on its back trimmed carefully.
We don't want to put it too far up. We don't want to put it on his head, and we don't want to put it too far back down his back. We want to keep the transmitter right here between its scapula. So I'll trim the fur gently, make sure I don't nip its back.
A non-toxic surgical adhesive is applied to the transmitter and the bat, followed by a 5-minute wait time to ensure a successful bond. The ground crew then releases the bat and informs the biologist in the airplane circling overhead.
She is ready to go. Josh 688 is on the wing.
Copy, that's the last one, right?
That is the last unique frequency, and I won't tell you when we start doing the shared frequencies unless you really want to.
No, just let me know when you're finished.
Copy that.
Once we release that bat, we have the night crew that is going to track the bat as it migrates. And you have the aircraft above, so you got the aerial support, and you've got a ground crew that's underneath them.
A select number of female Indiana bats are fitted with unique frequency transmitters. Antennas attached to the wing strut of the airplane can pick up a transmitter signal or beep within an approximate 3-mile radius. A closer proximity to the bat and its transmitter results in an increased signal strength and therefore louder beeps. The position of the strongest signals are then marked on a digital map, and the GPS location is relayed to the ground crew.
35511085310
In this way, we can see the trajectory that the bat is traveling. So we have a bunch of dots on a map, and once a bat starts going in a particular direction, it generally stays going that particular direction. This can be handy when you lose a bat for some reason, like the plane has to land or bad weather comes in. We learned very early on that this project is essentially not possible without an airplane. We had 3 or 4 ground crews the first year and tried to track the bat as it was migrating, and we were able to keep up with it for a couple of hours, and basically it went across Lake Cumberland in Kentucky and we couldn't get around the lake fast enough.
There have been times where we've had to go and refuel, and they've kept up with the bat for 10, 20 miles. Those ground crews, they anticipate where the bat's going as well.
The best part of this project is being a ground crew and tracking these bats at nighttime and anticipating where they're going to fly, plotting their course on the computer and hopscotching roads to get to that, to ultimately get to that tree. It's an ultimate rush.
Despite a team of researchers tracking the Indiana bat from both air and ground, there are a multitude of challenges to overcome during the spring migration.
First of all, the transmitter is really small and it does not transmit very far. Second, the bat is generally pretty low on the landscape, and oftentimes they can be in the streams and ravines, and which makes the signal even more complicated. It doesn't really emit out of those ravines very easily. You have to get in the right angle with the airplane. Also, the weather plays a huge role in migration of these little bats.
First couple of years it was anecdotal, like the bat would stop moving and we would kind of wonder why, and because it wouldn't be raining or anything. We'd write down the temperature and it's like, it's about 50 degrees Fahrenheit, and then it continued to happen. So we found that 50-degree weather is pretty much the stopping point for migrating bats, and also rain. Bats can fly in the rain, but in big thunderstorms they don't continue to fly. They'll find a roost tree and stay there pretty much for the night. The other thing that affects migrating bat behavior is high winds. Bats are very small. Indiana bats are around 6 to 7 grams in weight, and they're a small animal that's affected by wind gusts. And the plane is also affected by wind, so sometimes the plane can't go up, then usually the bat can't fly either.
It is a constant battle in the airplane when you have wind, and I'm flying at 3,000 or 4,000 feet. And the wind at that height is much different than it is on the surface. And when I'm flying into the wind, it's fine. The plane slows down. We're flying pretty slow. The bat's going pretty slow, so that's fine. But as soon as I start to turn and turn into the wind, I get blown. And sometimes I can get blown 4 or 5 miles off the bat.
So along the migration route, the bats will fly at night, but because they're nocturnal, they have to sleep during the day. We'll follow the bat as it's migrating at night, and then it'll stop and we'll get some sleep. And the next day, either the plane or the ground crew will go out and locate the bat as it's sleeping. Generally, this is a dead tree with the bark that is exfoliating from the bole of the tree, and the bat will get up underneath the bark, in between the bark and the bole of the tree, and they'll back up in there and snuggle in for the day, and they will sleep. Occasionally bats will use live trees, but generally trees that already have kind of bark that's popping off, so like a shagbark hickory. This time of year there's not very many leaves on trees, so the trees get a lot of solar exposure. And even though bats are mammals and they can regulate their own body temperature, they're not very good at it. So while they're asleep, instead of using their energy to regulate their body temperature, they sleep under a piece of bark that's going to get a lot of sunlight. So that way it can use its energy for migrating at night. Once we find the roost that the bat is sleeping in, we collect habitat data about that roost. So what is the species of tree? How big is it? How tall is it? What other trees are around it? What other species of trees? What kind of trees are they in terms of, do they have roosting potential? Are they dead trees? Are they live trees? So that way we get an idea of the habitat around the roost.
As the spring storms move in or nightly temperatures drop, these bats need to seek shelter, and sometimes they need to seek shelter quick because the storm's moving in, and having suitable roosts along that route is key for their survival.
In past studies conducted by Copperhead Environmental Consulting, the Indiana bat traveled from 50 to 230 miles, taking an average of 4 to 5 days to complete the migration. Therefore, the process of locating the roost trees will occur multiple times, and ultimately, the bat will reach its final destination, referred to as the summer grounds or maternity colony.
Determining the summer range can be a little bit tricky. Generally, if a bat stays in the same area and using the same tree or multiple trees in a small area for several days when there's really good weather, as in the temperature is above 50 degrees and it's not raining and not very windy, generally we can call that home.
Another indicator is that when we go and do exit counts out of the roost tree, is that bat roosting with other bats? And in the beginning, it's usually 1 or 2 bats, but once we start seeing multiple bats, that is a key indicator that that bat also has arrived at its summer destination. Also, habitat is our third one. I mean, the habitat around these maternity colonies is generally larger trees, a lot more trees with exfoliating bark.
We want to find the exact tree on the landscape, and a lot of times female Indiana bats have several trees that they use as a maternity colony, and they'll switch from tree to tree as they're raising their young.
In the first 5 years Copperhead Consulting has conducted migration research, 9 new maternity colonies have been discovered. In addition to discovering these areas, which are crucial for study and protection, it illuminates specific pathways from 2 caves that can aid tremendously with decisions about land management. This includes factors such as the removal of trees for development, wind turbine location, and light pollution. Furthermore, this information has uncovered that some Indiana bats have used nearly identical paths and roost locations en route to their summer homes.
By radio tagging nearly every female Indiana bat in a cave and then searching for them on the landscape has been a very useful tool for locating new maternity colonies.
Animal migration, especially bat migration, has been a mystery to us. Bats are small animals that are active under the protection of darkness and can fly quickly across the landscape. We are only now starting to get a glimpse of the mysterious processes involved as bats migrate from their winter hibernacula to summer habitat. How high do bats fly while migrating? How do they use landscape features such as rivers and ridges? How does weather change their behavior? And what impact might our actions have on bat populations? The answers to these questions are beginning to come to light, but there is still much to learn and understand. Identifying the needs and challenges faced during migration is key to ensuring that bats will continue patrolling our night skies for generations to come.